I am recording the video. Now look at the question. Okay. This is of chapter 6. RCC T-beam decking for the bridge. This is the portion of the bridge deck over the girder or the pier of the bridge. And the pier and the foundation portion is not shown here. Only the upper part of the beam, slab and the railing post as well as curb and the wiring coat is shown. This is the girder for the 1 meter span, 6 meters, single span of the bridge of 6 meter length. Okay, this is the cross section. This is shown from the cross section. The length of the span is 6 meter, and you have to provide the 45 centimeter bearing on the either side. That is total length of the bridge will be 6.9 meters, because 45 centimeter added towards the both the ends at the, and that is a rest on the abutment of the bridge. Okay, so this is the deck, T-beam deck. This is the shape of this beam, the beam that passes below the slab is at the shape of the T. So this is called the T-beam decking, and the data here is provided as the total width of the bridge span is 7.70 meter, and the railing post height is 1.20 meter. For the both sides, the railing post is provided. This is the section. These railing posts are the size of 15 by 15 centimeter, and these are separated by 138 centimeter center to center. Okay, and this is given in the question. And the lower portion of the slab, that is the beam portion. The beam is of the rectangular portion plus the fillet portion is along the beam. That's why this triangular portion, the triangular portion height and width is 15 by 15. That is 15 centimeter by 15 centimeter. The reinforcement bar provided for the beam slab as well as the railing post is considered as for the beam 2.5% of the volume of the beam, whereas for the railing post and the slab 1% of their volume is considered for calculating the reinforcement bar. We have to calculate the different quantities of item using this figure. Other data is given in the question. Okay, total length of this bridge span is 6 meter, and 45 centimeter bearing should be taken on the either side. So the length will be 6 plus 2 into 0.45 will be 6.9 meter. Okay, overall length will be 6.9 meter, and the cross sectional dimension is given here. Okay, after knowing this thing, you can calculate the different items of this T-beam decking for the bridge. Okay, now I think 12 people are present only. Um, um, Other students may come. I will start the course anyway. Okay, I will not wait for them. Let me start. Uh, Now look at this figure. Uh, from this figure, you know very well the TBM decay RCC TBM decking. Estimate the quantity of various items of work of RCC TBM for a bridge of one span of 6 meter. Section provided in the figure below. And the length is about 6 meter. Okay, as in 45 centimeter bearing on either side of the abutment. So the total length will be 6 plus 2 into 0.45. 6.9 meter will be the total length of each span. Okay, and the mild steel section reinforcement for 2.5% in the beam and the 1% for slab and the post. This is given here the for the steel reinforcement work. Now look at all the dimensions are provided here in meter. If other dimensions are given, they are specified in the question in the drawing. Okay, this is the cross section direction. The above the decking slab, above the decking slab, there is the wiring cord of 10 centimeter. That is the 7 meter width. The wiring course is given here. This wiring course is the layer from where the vehicle will travel. Okay, this is the vehicle will travel from the top of the wiring course. Over the wiring course, the vehicle will travel, and this is the T-beam decking. This is the cross section of the T-beam decking above the bridge girder or pier. This is the topmost portion of the bridge only. Now the for this we don't need to have the excavation. We did so that we can do only from the part of the RCC ore, PCC ore, PCC ore, and the plastering ore, pipe ore. ETC can be done for this part of the T-beam decking. So look at the figure. The first item may be RCC 1 is to 2 is to 4, excluding reinforcement ore. If you and there we do the reinforcement ore later, so that for the RCC ore the proportion of the RCC should be specified. Here the RCC the proportion is not specified, so I take the proportion of 1 is to 2 is to 4. Okay, without the reinforcement bar, the volume of the concrete should be calculated. Okay, the RCC work generally includes the RCC in drilling course, in cork, in slab and beams. Okay, these are the RCC portion. So the quantity of RCC work can be calculated separately for the different part of the girder. Okay, now for the beam, there are three numbers of beam. You can see here there are three numbers of beam below the slab. The beam size is rectangular plus triangular. Okay, three rectangular and two triangular part for each beam. So that the number of fillet part for the beam will be 6. Okay. Now for the ribs, that is the rectangular part of the beam. There are three numbers of the rectangular part of the beam, and the length of the beam will be 6 meter span and 25-meter bearing on either abutment. So that 6 plus 2 into 0.45, which gives the value of 6.90 meter. Okay, and width of the beam is 0.35. Look at the figure. The width of the beam is given as 0.35 and the height of the beam is given as 0.75. That data is not there, but I put the value of the thickness of the height of the beam as 0.75 meter below the slab. Okay, this is given here, and after multiplying number, length, breadth, and height, you will get the quantity of the RCC for the rectangular portion. Now the beam has the fillet portion also. That is the fillet portion is the triangular portion. For each beam, there are three beams. Each beam contains two numbers of fillet. So that two numbers of fillet is there. The length of the fillet is same as that of the length of the beam. So its value will be 6.9 length. And the area of the each plate is half 0.15 into 0.15 because the perpendicular and base of the fillet is given as 15 by 15. Okay, in the question, so that you can take the 15 centimeter in terms of centimeter is given here, making the centimeter into the meter. The area of this each triangle of the plate will be half 0.15 into 0.15. This cross-sectional area is multiplied by length of the beam. You will get the volume of the total fillet portion of the beam. Okay, so that total number of fillet is 6, 3 into 2, and the length will be same as the beam 6.9. And the area of each plate is half 0.15 into 0.15. You will get the total quantity as 6 into 6.9 into half 0.15 into 0.15. You will get the value of 0.047 cubic meter. Okay. For the second part, that is done up to the portion below the slab is calculated. Okay. Now for the deck slab, the slab thickness is given as 200 0.200. That is 20 centimeters is provided here. You can see at the left right hand side, the thickness of the slab is given as the 0.20 meter. Okay, and the total length of the slab is 7.70 meter from the right corner end to the left corner end. The total length is width is 7.70 meter. Okay, and the length is along the longitudinal direction of the section. The longitudinal direction of the section is total 6.90 meter, as we have already calculated. Okay, so for the deck slab, there is deck slab is one number, and the length of the slab is similar to the length of the beam, so as the 6.9, and the width is 7.70 from the right corner to the left corner, taking the beam portion only, which is 7.7, and the thickness of the beam is 0.20. Okay, thickness of the beam is 0.20, and the thickness height is given there, and the multiplied length, breadth, and height, you will get the quantity of RCC work for the deck slab. Okay, now there is core portion there. Core portion is given as 20 by 20 core portion. That is the above the deck slab. There is the core portion, and at the side of the deck slab there is the railing post. Okay, railing post size is 15 by 15. That is 15 centimeter width and 15 centimeter length, and the height is 1.20 meter. 120 centimeter height means 1.20 meter. So up to the end of the railing post, the total width will be 20 plus 0.20 plus 0.15, which gives the value of 0.35, and the height of the curve is 0.20. So the sectional area of the curve will be 0.20 into 0.35. Okay, and this length of the curve is this is also passing along the longitudinal direction of the bridge. So that length will be 6.9. Okay, the curve length will be 6.9, and the width will be 20 plus 0.35, and the height will be 0.20. Okay, this gives the value of the curve. The curve for the left portion and the right portion, two numbers of curves are there, two numbers, and the length is 6.9, and width is 0.35. That 0.35 is taken for the top width of the curve plus the portion of the railing post. Okay, that is occupied by the railing post also. The railing post is provided above the curve, so that this portion is added here, 0.20 plus 0.15, which gives the value of 0.35, and the height of the curve is 0.20, provided in the question as 0.20. You can see here, and the total volume of the RCC work for the curve would be 0.966 cubic meter. Hello? Do you all understand this? Hello?
Yes, sir.
Now, up to this curve. Now we have to find the quantity of RCC for the railing post. Okay, the railing post is shown in this cross section is only two numbers, because it is shown from the sidewise, because another railing post is behind this railing post at the center to center distance of 138 centimeter center to center. So we have to provide the number of railing posts for each side. Will be total length of the bridge. Total length of the bridge is 6.9 meter. The center to center distance is 138 centimeter. So 6.9 is divided by 1.38, plus one number is extra, one number is added for the initial point of the bridge. So the railing post you can be calculated for the single side. Okay, for the single side, the number of the railing post will be total length of the bridge span is 6.9 meter. That is divided by the spacing of the railing post, 1.38 centimeter. That is 1.138 centimeter. That is 1.38, plus one number is added for the initial point. So that you will get the number of the railing post for each side. Okay, and for the double side, the number of railing posts will be 2 times that the railing post along the one side. Okay, so that the number of railing posts is calculated here. The 6th number of railing posts is calculated as total length of the bridge is 6.9 divided by the spacing of the railing post, that is 1.38, and one number is added for the initial starting point of the railing post. So that one is added here. You will get the value of 6. Okay, 6 for each side, and for the double side, the total number of railing posts will be 6 into 2. Okay, the railing post for the total number of railing post is 12, and the length of the railing post is 0.15, width is 0.15, and height is 1.20 given in the question. Okay, size of the railing post is 15 by 15, that is 15 centimeter length, 15 centimeter width, and the height is 1.20 meter, that is given in the question. Number of railing post is 12, and for the 12 railing post, the total RCC work will be 0.224 cubic meter. After adding all the quantity of the RCC, you will get the total quantity of RCC as 17.397 cubic meter. Hello? यो बुझ्यौ मैले गरेको?
बुझ्यो सर, बुझ्यो।
यो मैले सेक्सनमा यहाँ देखाएको छु, रेलिङ पोस्ट कसरी बसेको छ भनेर। त्यो बेला छेउबाट हेर्दाखेरि यो छेउकै रेलिङ पोस्ट देखियो, यो छेउकैले अरू रेलिङ पोस्ट छेकेको छ, हो कि होइन? यो रेलिङ पोस्ट चाहिँ एउटा रेलिङ पोस्टको बिचदेखि अर्को रेलिङ पोस्टको बिचसम्म 138 सेन्टिमिटर छ है। त्यो भनेको 1.38 मिटर चाहिँ सेन्टर टु सेन्टर डिस्टेन्स भयो। रेलिङ पोस्टको साइज 15 बाई 15 को साइज छ, हो कि होइन? अब कर्भ छ, रेलिङ पोस्ट भन्दा यतापट्टिको भाग रोडतिरको भागमा चाहिँ 20 छ, रेलिङ पोस्टतिरको भाग 15,035 भयो त्यो कर्भ। अनि हाइट कति छ? कर्भको हाइट 20 छ है, भित्रसम्म कति गएको छ? 20 गएको छ भने अब यसरी चाहिँ रेलिङ पोस्ट एउटा साइडको मैले यसरी देखाएको, अर्को साइडमा पनि यतापट्टि हुन्छ भनेपछि अब नम्बर अफ रेलिङ पोस्ट यसरी 6वटा यसरी आएको हो है। 6वटा रेलिङ पोस्ट ल्याउनलाई टोटल लम्बाइ कति छ हाम्रो? यो 6.9 छ। यो डिरेक्सनमा कति छ हाम्रो? टोटल लेन्थ कति छ? 6.90 छ भने अब 6.90 टोटल लेन्थ चाहिँ हाम्रो छ यो ब्रिजको भने अब त्यो 6.90 लेन्थमा कतिवटा चाहिँ रेलिङ पोस्ट चाहियो त भन्दाखेरि यो 6.90 डिभाइडेड बाई द स्पेसिङ अफ द रेलिङ पोस्ट गऱ्यो भने, स्पेसिङ गऱ्यो भने 5वटा आउँछ, प्लस एउटा थप्नुपर्छ छेउको लागि भने +1 गऱ्यो भने 6वटा आउँछ है। त्यो 6वटा आएपछि 6 नम्बर भयो कि। अब एउटा रेलिङ पोस्टको भोल्युम कति भन्यो भने रेलिङ पोस्टको चाहिँ एरिया कति हुन्छ हेर्दा 0.15 बाई 0.15 हुन्छ एरिया, हाइट कति छ? 1.20 भनेपछि त्यो रेलिङ पोस्टको भोल्युम निस्क्यो नि। एउटा भोल्युमलाई 12वटाले भोल्युमले मल्टिप्लाई गऱ्यो भने टोटल भोल्युम निस्क्यो होइन त। 6वटा यतातिर 6वटा अर्को साइडमा हुन्छ, त्यो भएर यसरी चाहिँ हाम्रो चाहिँ रेलिङ पोस्ट निस्केको हो है। Now okay, this is the first item. I think you can understand this how I calculate the value of 6, and for the double side it is multiplied by 2. Okay, the area of each railing post is 0.15 into 1.2, and the total volume of the volume of railing post will be that is multiplied by the 12. Okay, you will get the value of 0.324 cubic meter. Now the total RCC work will be 5.434, 0.047, or 10.626, 0.966, 0.324. Add them all, you will get the value of 17.397 cubic meter. In the remark column, I have mentioned the how I calculate 6.9. The 6.9 is not given in the question. In the dimension you cannot see the 6.9 value. So how this 6.9 is calculated? 6 meter is clear span plus 2 into 0.45 for the 45 centimeter pairing. That is 45 centimeter is converted into meter. That's why 2 into 0.45 for the pairing on the abutments. So that is added for the 6. So you will get the 6.9. Okay. Other 0.35 and 0.75 these dimensions are provided in the figure. Okay. For the fillet, the size of the fillet is given as 15 by 15. The area of each fillet will be half 0.15 into 0.15, and the length of the fillet is similar to the length of the beam, and so the length of the beam is 6.9. After adding the area of the fillet and the length of the each fillet, you will get the volume of each fillet. We have the 6 numbers of fillet there, so after multiplying with 6 you will get the total volume occupied by all the fillets. Okay. and that will be 0.047. In this way, we have calculated this. You can understand all these terms. Okay. Now for the secondary, mild steel reinforcement work including bar bending and placing. That is generally calculated in the quintal. Okay. The beam and the beam for the beam, 25% of the volume of RCC of beam is considered here. So generally the beam is for the rectangular portion of the beam, it is the reinforcement is calculated up to the top surface of the slab, below the wearing board. That's why there is 3 numbers of the beams having the rectangular plate. The length of each beam is 6.9 meter, and the width of the beam is 0.35, and the height of the beam is width of the beam is 0.35, and the height of the beam has to be calculated. Okay, the height of the beam is calculated as 0.95 here, because 0.75 is the height below the slab, and up to the slab top the height 20 centimeter is added, so that its value will be 0.95. Okay, the height of the beam will be 0.95, and that 0.9, this is the volume of the beam. 3 into 6.9 is 0.35 into 0.95 will be the volume of the beam. That is multiplied by the percentage of the steel reinforcement. This volume is multiplied by the percentage of the steel reinforcement. 2.5%. If you divide by 100, you will get the value of 0.025. Okay, and that is multiplied by 0.025 into the density of steel is taken as 78.50 quintal per meter cube volume. Okay, 78.50 quintal per meter cube volume. You can multiply that. This is the density of the steel as 78.50 quintal per meter cube of the RCC. You will get the value of 13.51 quintal. Okay, 2.5% volume of the RCC. The volume of RCC is taken for the rectangular portion only, and the rectangular portion 3 numbers volume will be you have calculated 3, 6.9, 0.35 into 0.75 height is here. Don't look at the 0.75 height. Go to the height up to the slab. Thickness for calculating the steel reinforcement bar. Okay, so that I have taken the 0.75 plus 0.20, you will get the value of height as 0.95. Up to 3 into 6.9, 0.35 into 0.95, the volume of beam is calculated, and the 2.5% of this volume is considered for the calculation of the steel reinforcement work. So the 2.5% is converted into decimal as the 0.025 into, and the density of steel will be 78.5 quintal per meter cube. Okay, after multiplying this, you will get the value of 13.51 quintal. Now for the deck slab, the deck slab volume is for the deck slab is the 1% is taken, so that the 0.011% into volume of the deck slab is 10.626. That is already calculated in the serial number 1. That is 10.626. That volume of the slab, and multiplied by the density of the steel as 78.50. You will get the value of 8.34 quintal. 1% is converted into decimal. 0.01 into volume of the deck slab calculated in the RCC, that is 10.626, volume of the slab into density of steel 78.50. You will get the value of 8.34 quintal of steel reinforcement bar for the slab portion. Slab portion. Okay. Now for the railing post. For the railing post, 1% is provided here. The railing post is 0.324. Its volume is 0.324, and the percentage is 1. 1 is converted into decimal, 0.01 into 0.324 into 78.50. You get the value of 0.25 quintal. The total mileage reinforcement work will be 22.10 quintal. Okay. If you want to provide the carb, I have all the carb portion is also missing here. For the carb portion, in the question the carb portion reinforcement is not given provided here, so that we have only considering the rectangular rectangle beam, slab, and the railing post is considered. Okay. Now, for the 3, the PCC for wiring code. This is the CC. CC is given for the wiring code. CC is given for the wiring code in this figure. You can look at the figure. 10 centimeter wiring code CC. CC means cement concrete. This is only cement concrete. It does not contain the reinforcement bar. So this is the only plain cement concrete. 10 centimeter wiring code. That the wiring code is average thickness of 10 centimeter, and its area will be length into breadth into height. Its area will be length into breadth, and this length into breadth is multiplied by the thickness. You will get the volume of the wiring code. Okay. Now the wiring code. Look at this figure. The width of the wiring code is in between the curve. In between the curve, the width of the wiring code is equal to the width of the roadway. That is the 7 meter. Okay. And the length is similar to the length of the bridge. That is 6.9 meter. Length is similar to the length of the bridge along the longitudinal direction. Along the cross section direction, the width is 7 meter. Okay. Now you can find the volume of the wiring code as volume of the PCC for wiring code. The wiring code is number 1. There is one number of wiring code is here. The length of the wiring code is the length of the bridge span, that is 6.9, and the width of the wiring code is given as the width of the road 7.0, and the thickness of the average thickness of the wiring code is 0.10. There is given. That thickness is height, and multiply all these things, you will get the volume of the wiring code as 4.83 cubic meter. Okay. Total volume of the wiring code will be PCC for wiring code will be 4.83 cubic meter. It is, if there is you can provide the proportion of the wiring code also. You can provide the proportion of the wiring code also here, 1:3:6. Okay, you can provide such proportion also. Now for the 40 mm diameter GI pipe railing in railing, that is you can see here in the figure. In the figure right hand side, there are the 4 numbers of circular holes. You can see in the figure of the post of the in the railing post, you can see the 4 numbers of these circular holes. Okay, right hand side, you can see in the right hand side there are 4 numbers of the circular holes. These are the portion of the 40 mm GI pipe of 4 numbers. Okay, these are the portion of the railing post. In the railing post, the railing is done by using the 40 mm diameter galvanized iron pipe. Okay, so we have to calculate the pipe length. Generally, pipe is described as the diameter of the pipe and measure in terms of the length. Okay, so we have to calculate the total length of the pipe required for the railing purpose. Okay, so total length of the there are 4 numbers of pipe is required. Okay, the diameter of pipe must be specified, and the length of the each pipe is calculated. Okay, now look at this. For the single side 4 number, single side here 4 number, and the single side here also. Here is not shown here, but in the double side there will be the railing post. So you have to calculate a railing post for the double side. Okay. You must know the concept now. For the single side, there are 4 numbers of the pipes. 4 numbers of pipes. For the double pipes, you need that 8 numbers of pipe. Okay. Each length of each side, for each side, the length of the pipe will be the total length of the bridge. That will be 6.9. Okay. Diameter has to be specified, and the number of pipe has to be specified, and the length of the pipe is calculated. The length of the pipe is 6.9 meter as the length of the bridge span. Okay. Now the total length of the pipe will be 8 into 6.9. You will get the value of 55.20 meter. Hello. The total length of the pipe will be 8 into 6.9. You will get the value of 55.20 meter. Okay. This is the pipe hole. Pipe is specified in diameter and measured in length. Okay. running meter, so that it is measured as meter, running meter. Now for the another item, 12.5 mm thick 1:3 cement and mortar plaster over exposed surface square meter. Generally, for the concrete work or the brick work or the short work, that in the bridge, these works are rendered by the plastering work. Okay, so I have considering the 12.5 mm thick cement plaster of 1:3 cement and mortar over the exposed surface. That is the plastering is measured in the square meter. So you can look at the figure here. Slab sides up to curve, bottom and beam as total. Okay, the portion for the calculation of the total slab sides up to curve bottom, up to curve bottom and the beams as total. Okay, this is taken as this is the you can calculate the total plastering for the surface. That is from this curve, below this curve up to this slab. Below this curve up to this slab, you have to provide a plastering like this. Along the cross-sectional direction, you can calculate the total perimeter of the plaster up to here. Okay, from this point, from this slab thickness is 220 centimeter. This is 20 centimeter. You move here, up here, down here, and again below the beam, again up the beam, inclined portion of the fillet, again this horizontal portion, again inclined portion, vertical portion, horizontal portion, vertical, horizontal. In this way, you can calculate the total perimeter up to the top of the slab. Okay, up to the top of the slab, you can calculate the total perimeter of the length, and perimeter length, and that is multiplied by the total length of the bridge. You will get the plaster surface for that point. Okay, so that I have done. Now look at this. How can I calculate the value of 12.47 along the wood quote? The 12.47 is 7.7. That is the total length of the deck slab. Okay, plus 2 into 0.20 plus 0.20, 2 times 0.2 into 0.2 value, and plus 0.75 into 6 minus 2 into 6 into 0.15 plus 6 into under root 2 into 0.15 square. If you calculate in this way, you can find the value of 12.47. Okay, that is you can see here 7.7 is the total length. Total length of the slab. The bottom portion of the slab will be total length will be 7.7. Okay. You can add 2, 0.20 and 0.20 here for the left and right side. This will be 0.20 into 2. Okay. And you can add the value of and you can add the extra length for the inclined portion. Extra length for the inclined portion, that is the that is 1, 2, 3, 4, 5, 6. 6 times that extra length for the inclined portion is calculated as 6 times under root 2 into 0.15 square. Okay, 6 times under root 2 into 0.15 square minus 6 times 6 into 2, 12 times the 0.15 value, and the plus 0.75 into 6. That is 0.75 into 6 is the height of the height of the beam up to the slab, that is 0.15 into 2. You should not multiply. This is 0.2 is multiplied here. Double time is multiplied here. Okay. This is 7.7 plus 0.4 plus 0.76 5 into 6, 0.75 into 6, 6 into root 2 into minus bottom and the rest of the two. This is ready. Now I have done the plastering from this top surface of the this is car up to this level, sides up to the top level, and this is 40, this is 40, and this is 40. 2 times 40, that is 0.8. Okay, and from here to for total base of the slab, bottom portion of the slab is 7.7. 7.7. It includes the horizontal portion of the slab as well as the beam base. It includes that value. That will be total will be 7.7. Okay, 7.7. 2 into 0.2, 0.2 double side plus bottom width of the slab 7.7, and you have to subtract the value of subtract and 6% of this vertical height of the rib will be 0.75 into 1, 2, 3, 4, 5, 6 for the 6 into 0.75, and the minus you have to subtract the this fillet portion, horizontal as well as vertical. For the 6 plate, you have to subtract the 12 number of the 0.15 part. So the 2 into 6 into 0.15, and you have to add the inclined portion. You have to add the inclined portion 1, 2, 3, 4, 5, 6, and you will get the total perimeter of this perimeter of the plaster surface along the cross section direction up to the slab up to the curved top. We'll get the value of the width as 12.47 meter. Okay, 12.47 meter, and that width is multiplied by the length of the span, length of the bridge. You will get the total portion of the plastering of that portion. Okay, slab sides up to curved top, bottom, and the beam as total. Slab bottom and the beam as total. You will get the cross sectional length as the 12.47. That is 7.7 bottom portion. 2 times 0.2020. This is the core portion and the slab side portion. 0.75 into 6. This is the beam vertical portion. Minus 2 into 6 into 0.15. That is the beam fillet portion, vertical and horizontal part is deducted, and the fillet portion inclined part is added. Okay, fillet portions inclined part is added. This is the total width of the plaster along the cross section direction up to the slab up to the curved top. This is the total is calculated in this way. So 12.7 is considered as breadth, and the length of the bridge is 6.9. Length into breadth, you will get the value of the plaster surface. Okay. For the remaining part is curved top and side. For the curved top and side, you can see the look at this figure. For the curved top and side, this is the top of the curve. The top of the curve has the width of 20 into 50, plus 15, 35, and the length is 6.9 here. This top is length, and this side, the below this top, there is the 20 centimeter curve height, and for which 10 centimeter is filled up by the wiring cord. Remaining 10 centimeter can be plastered. Okay. Horizontal side 20 into plus 15, and the vertical side will be 10 here. 10. So that the total surface area will be 35, 0.35 into 0.10 into 6.9. Okay, 6.9, 0.35, 0.10 will be the plastering for the curve top and the inner side. Okay, you will get the value of, we can calculate in this way. That is, you can look from here also. This is the curve portion. This vertical height above the wiring cord is 10, and this horizontal portion is 20. 10, This is 20, and up to this up to the end of this core portion, this total length is 0.35. Okay, so so for the second core top and sides, core is of 2 numbers for the left and right hand side. The length is 6.9. Okay, and the breadth is 0.45 because the breadth is considered as the 0.35 as the top and the 0.10 as the sides. Okay, vertical sides. In total, you can calculate the 0.45. 0.10 plus 0.35 will get the 0.45. The 0.45 is calculated as 0.15 for the pillar portion, and the 0.20 for the portion beyond the pillar, and the 0.10 is the vertical portion of the core. Okay, that is exposed to the surface, that has to be plastered. And the railing post, faces is given as railing post is of 1.20 meter height. So that for the railing post there are the 4 faces because the railing post is of square shape. So there are 4 faces of the railing post. There are altogether 12 number of the railing posts for the 6 number of each side, and the 12 number of railing post of plaster will be 12 number railing post, and the 4 faces for each number. Okay, and the railing side railing post is face width is 0.15 and height is 1.20. You can get the value of 15.12 square meter. Now deduction for bottom bearing for the beam. The bottom bearing for the beam is deducted because we have calculated all the, while calculating the this A slab side up to core, beam top or bottom, and the beam as total, we have calculated this portion also. While taking the 7.70 width, this portion of this beam portion below bottom portion of the beam also taken as 7.70, but this portion is raised over the girder or the pier, so that in that section we cannot do the plaster for the bearing portion only, so that this bearing portion bearing resting portion of the bottom portion of the beam has to be deducted. Okay, for this we have the 3 numbers of beams. The width is 0.35. The length of the beam will be bearing length, that is 0.45 only. Okay, that is deducted here. Deducted for the bearing portion. Deduction for the beam bearing portion. The beam has the 3 numbers of beams, and the bearing portion for each beam there is 2 bearing portion. One for the left bank and another for the right bank. Okay, so that you have to consider 2 bearing portion as 6. For 3 beams there are 2 bearing portion for the left bank as well as the right bank. Okay, 2, and the length of the bearing portion is 0.45 and the width of the beam is 0.35. You have to deduct this. This will be the negative quantity. This is minus 0.945. After adding all the quantity, after adding all this quantity and deducting this quantity, you can get the cement plaster of 106.428 square meter. Okay, hello. For the portion of the slab or beam on the ends, and that is being filled up by the road metals. That's why you cannot you don't need to plaster for the ends along the longitudinal direction of the road. Okay, ends along the longitudinal direction of the road, that is being hide by the that is being hidden by the road or metal surface. Okay, and for that portion you should not plaster. So this is the plaster quantity as 106.428 square meter. In the examination, you may be asked up to the question number 4. If you are provided with the plastering also, then you have to calculate the plaster area by considering the exposed surface of the deck. Okay, this is the plastering. Up to this, the tutorial for calculating the T-beam decking is finished. This is the figure. With this figure, you can calculate up to serial number 4 is compulsory. Up to serial number 4 is compulsory, and this serial number 5 is mandatory. Sometimes it may be asked in the examination also. In that case, you can do like this. Okay, up to serial number 4, it is compulsory. You may be asked to find the quantity up to serial number 4 in the examination generally. Okay, if the plastering is considered, plastering has to be also has also to be calculated, then you can do plaster calculation like this. Okay, hello.
डिडक्सन को एक बार फिर भन्नु
हेलो,
डिडक्सन वाला भन्दिनु
यो डिडक्सन को बुझेनौ?
एक बार फेरि भन्दिनु
यो बीम त कहाँ बस्छ? बीम त एबुटमेन्टमा गएर बस्छ नि त। जहाँ बीमले टेकेको छ, बीमको मुनि त प्लास्टर गर्न मिल्दैन। त्यो प्लास्टर गर्न नमिल्ने भागलाई घटाएको। बुझ्यौ? यो तीनटा बीम छ, दुईतिर टेक्छ एबुटमेन्टमा भनेपछि त तीनटा बीमको दुईतिर टेकेको भए कति? एबुटमेन्टको चाहिँ हाम्रो चाहिँ बेरिङ कति दिएको थियो? 45 सेन्टिमिटर। जहाँ टेकेको पोर्सन छ बीमले, त्यो टेकेको भागमा त तिम्रो के गर्न मिल्दैन? प्लास्टर गर्न मिल्दैन। बुझ्यौ? अब यो भने के हो त भन्यो भने जस्तो हेर है, तिमीलाई म सिम्पल देखाइन्छु। सपोज दिस इज द बीम है, यो बीमले यो एबुटमेन्टमा यहाँ टेक्यो, यो एबुटमेन्टमा बीम सपोर्ट भएर बस्यो यसरी। बीम यसरी दुईतिरको एबुटमेन्टमा गएर बस्यो, सपोर्ट भएर टेक्यो भने अब तिमीहरूले हेर त यहाँ अलिकति कन्सेप्ट बुझ्नुपर्छ है। कन्सेप्ट बुझेन भने गर्न सकिँदैन। ल सपोज यो चाहिँ बीम हो, बीममाथि अब यसरी बसेको छ भने यो टोटल स्पान यहाँदेखि यो भित्रदेखि भित्र 6 मिटर हो। यो 45 सेन्टिमिटर यता टेक्यो, 45 सेन्टिमिटर यता टेक्यो भने बीमको तलपट्टि तिमीले प्लास्टर गर्न मिल्छ। खाली भागमा त प्लास्टर गर्न मिल्यो। जब जहाँ टेकेको भाग छ नि, जहाँ बसेको भाग छ, त्यो बसेको भागको तलपट्टि प्लास्टर गर्न मिल्छ? हेलो, मिल्दैन नि। नमिलेपछि त प्लास्टर गर्ने भागको त हामीले तलदेखि माथिसम्म गरिरहेको छ, त्यो भागलाई पनि ल्याउँ होइन। जहाँ टेकेको भाग छ, त्यो टेकेको भागमा मिल्दैन, त्यो भाग घटाउनु पर्यो के। त्यो घटाउनको लागि के गरेको त भन्दाखेरि एउटा बीममा दुईतिर चाहिँ घटाउनु पर्यो। एउटा बीम, तीनटा बीम छन् भने तीनटा बीमको दुईतिर घटाउनु पर्यो, प्रत्येकको दुईतिर घटाउनु पर्यो। 6वटा पोर्सनमा भयो जस्तो है, घटाउनु पर्यो। कति? यतापट्टि 0.45, यतापट्टि 0.45, 0.45 घटाउनु पर्यो के। कुरा बुझ्यौ? अनि बीमको विड्थ त अर्को डिरेक्सनमा देखिएको छ, 0.35 विड्थ छ रेक्टेङ्गुलर पोर्सन। अनि त्यो विड्थले के गरे मल्टिप्लाई गर्यो नम्बर, यो लेन्थ बेरिङको लेन्थ प्लस विड्थ गरे, टोटल नम्बर अफ द बेरिङ गरेपछि के आउँछ त भन्दाखेरि डिरेक्सन गरेको पोर्सन आउँछ। बुझ्यौ यो? हेलो, यो त सिंगल बीमको हो, यो लङ्गिट्युडनल डिरेक्सनमा देखाएको हो। यो क्रस सेक्सनको डिरेक्सनमा त यो हो नि। क्रस सेक्सनको डिरेक्सनमा देखिएको यो हो। यहाँ तल बीम छ क्या, यहाँ मुनि के छ? पिलर छ, पिलरमाथि यो टेकेको छ। म्हणजे पिलर माथि बसेपछि रेस्ट गरेपछि त एबोटमेन्ट माथि बसिसकेपछि त बसेको जहाँ टेकेको भएको छ टेकेको भएको मुनि त प्लास्टर गर्न मिलेन नि, बुझेनौ? क्रस सेक्सन
बुझेँ सर,
ल तीनटा बिमको दुईतिरको इन्ट गर्दा कतिवटा भयो? 3 दुना 6वटा भयो। 6वटा भागमा 0.1545 को भाग घटाउनु पर्यो। विथ दिन्छु 0.45 गर्नु पर्यो 6वटा भागको है। सकिएको त त्यही गरेको, त्यो चाहिँ घटाएको हो। बुझाउनलाई त्यो गरेको अरू के पनि हैन। ल यो चाहिँ के भयो त भन्दाखेरि हाम्रो टिबिम टेकिङको जाँचमा सोधेको छ धेरैचोटि। फिगर त अब साइज फरक हुन सक्छ, यस्तै यस्तै खालको चाहिँ फिगर सोधियो, त्यो फिगर आफूले बुझ्नु पर्यो है। जाउँ अब हाम्रो 7 सम्म हो। सेकेन्ड क्वेसन हेर, क्याल्कुलेट द क्वान्टिटी अफ भेरियस आइटम्स फर द सेप्टिक ट्याङ्क एन्ड द सोक पिट। दिस इज फर द 6.11. दिस इज फर द 6.11 heading. We have done 6.3, 6.4, 6.5, 6. T-beam taking is 6.10 or something. T-beam taking is 6.10, I think. 6.10 or 11, I think. 6.10. 6.10 is T-beam taking. Okay. Now 6.11. The 6.11 heading of the 6th chapter, and there is the septic tank and the soak pit. This is the figure of the septic tank and the soak pit. The figure may be different, the figure may be same, the dimension may be different. You have to understand the figure. Okay. The left hand side portion is the section of the septic tank. Right hand portion is the section of the septic tank. Whereas the left hand portion is the section of the septic tank, whereas the right hand portion is the section of the soak pit. Okay, and from the toilet, the waste product is it enter into the septic tank through this inlet pipe. Okay, this is the inlet pipe, and the septic tank is the watertight tank. Septic tank is the watertight tank, and the bed of the septic tank is provided at the slope in 1:20. Okay, bed of the septic tank is provided at the slope of 1:20, and this septic tank has the 2 chambers. This is the inlet, this is the chamber first, and beyond this the baffle wall. The baffle wall is nothing. This is the curtain wall. पर्दा जस्तो वाललाई हामी के भन्छौँ? baffle wall भन्छौँ है। यो baffle wall को तलपट्टि खाली छ। यो यताबाट आएको वेस्ट प्रोडक्ट चाहिँ नि, यो वेस्ट प्रोडक्ट चाहिँ अब यो फ्रेस चाहिँ टोयलेटबाट आएको वेस्ट प्रोडक्ट चाहिँ के हुन्छ त भन्दाखेरि यो पानीमा उत्रिन्छ। यो पानीमा तैरिने भएको हुनाले यदि यो ब्याफल वाल बनाइदिएन भने यो वालले यसलाई छेक्छ र यतातिर जान दिँदैन है। यो पानीमा तैरिन्छ, अनि यो डिकम्पोज भएपछि बल्ल यो डाउनवार्ड गएर यताले गएर यो पाइपबाट फेरि यो बाहिर निस्केर कहाँ पुग्छ त भन्दाखेरि कन्टिन्युअसली चाहिँ कन्टिन्युअस छ। कन्टिन्युअसली हाँडो चाहिँ यो सोक पिटलर खसालिन्छ है। यो चाहिँ अब यो ब्याफल वाल बिचमा चाहिँ बनाएको छ। ब्याफल वालले चाहिँ नि यो भर्खरै टोयलेटबाट आएको चाहिँ आचीलाई चाहिँ नि यो डिकम्पोज भएको आचीसँग चाहिँ मिसिन दिँदैन यो ब्याफल वालले है। अब इनलेटबाट वेस्ट प्रोडक्ट आयो र यो च्याम्बरमा आएर थुप्रिन्छ ब्याफल वाल भन्दा लेफ्ट ह्यान्ड साइडतिरको च्याम्बरमा, एन्ड आफ्टर डिकम्पोजिसन this will move towards the next chamber, right side of the baffle wall, and the waste product will be passed to the soak pit through the outlet, through this outlet pipe. Okay, and this outlet pipe is continuous up to this soak pit, and this decomposed waste product is collected in the soak pit, and in the soak pit the solid portion as well as the liquid portion of the decomposed material is is entered into the soak pit, and the soak pit absorbs the liquid portion of the waste, decomposed waste, and the remaining the solid portion will be remain on this in this soak pit. After sometimes you can use this decomposed waste product as the manure for the vegetables and the crops sown in the kitchen garden. Okay, so this can be utilized later after drying. This can be utilized later as the fertilizer for the organic fertilizer for the crops and vegetables later. Okay, this is the section view of the septic tank and the soak pit. Septic tank ले टोयलेटबाट आएको वेस्ट मेटेरियललाई डिकम्पोज गर्ने काम गर्छ। यहाँ ब्याक्टेरियाहरू हुन्छन्, त्यो ब्याक्टेरियाले यसलाई डिकम्पोज गरेर सिम्पल मेटेरियलमा कन्भर्ट गर्छ र त्यो डिकम्पोज भएको वेस्ट चाहिँ कहाँ जान्छ त भन्दाखेरि यो सोक पिटमा जान्छ। सोक पिटमा जाँदाखेरि पानी र लेदो सहितको चाहिँ कहाँ पुग्छ त भन्दा सोक पिटमा जान्छ। सोक पिटले चाहिँ के गर्छ त भन्दाखेरि पानी जति सोच्छ र सोक पिटभित्र चाहिँ अब के बाँकी रहन्छ त भन्दाखेरि सोलिड पोर्सनहरू बाँकी रहन्छ। त्यो सोलिड पोर्सनहरूलाई चाहिँ निकालेर हामी के गर्न सक्छौँ त भन्दाखेरि मलको रूपमा प्रयोग गर्न सक्छौँ है। अब यसमा हेऱ्यो भने यो यिनीहरू दुईटाको सेक्सन हो। त्यसपछि यसको तलपट्टिको फिगरलाई हेऱ्यो भने यो दुईटाको प्लान हो। यो सेप्टिक ट्याङ्कको प्लान हो, यो चारपाटा परेको। यो सर्कुलर चाहिँ के हो त भन्दाखेरि यो चाहिँ नि सोक पिटको प्लान हो। भनेको सोक पिट यहाँ चाहिँ सेक्सनमा चारपाटा देखिए पनि सोक पिट के छ सर्कुलर सेपको छ भने सेप्टिक ट्याङ्क चाहिँ रेक्ट्याङ्गुलर सेपको छ है। अब यो सेप्टिक ट्याङ्कको चारैतिर चाहिँ गारोहरू लगाएको छ, वाल लगाएको छ। त्यो वालको साइज छ, यो माथिको वाल यहाँ सेक्सनमा हेऱ्यो भने तिमीहरूले सेक्सनमा हेऱ्यो भने माथिको वाल 20 को थिकनेसको वाल छ। यो 20 को थिकनेसको वाल यो माथिल्लो वाल भयो है। त्योभन्दा तलपट्टि 30 को थिकनेसको वाल छ। यो 20 को छेउदेखि यो सेतो भएको यो 30 को वाल हो। 30 को वाल माथि 20 को वाल बसेको छ। 30 को वाल माथि 20 को वाल बसेको छ। यो 30 को वाल चाहिँ पिसिसी माथि बसेको छ। यो 30 को वाल चाहिँ बाहिरको यो पिसिसी भएको छ नि, यो पिसिसी को भागमाथि चाहिँ यो के बसेको छ 30 को वाल बसेको छ हैन। यो पिसिसी चाहिँ नि बाहिरदेखि भित्रसम्मको पिसिसी गरेको यो ठुलो चारपाटा भागमा के रहेछ तलपट्टि पिसिसी गरेको छ। अनि भित्रपट्टि पनि के गरेको छ, यो भित्रपट्टि पनि पिसिसी गरेको छ। यो ट्रायंगुलर पोर्सनमा पनि के गरेको छ पिसिसी गरेको छ है। अनि यहाँ गारो उठाएको छ, तलपट्टिको 30 को गारो छ, माथिपट्टिको 20 को गारो छ। यो 30 को गारो यो छेउदेखि यो सेतो भागसम्मको 30 को गारो हो। अनि यो भित्रदेखि भित्र चाहिँ कतिको गारो हो त, यो जुन ह्याच गरेको पोर्सन चाहिँ 20 को गारो हो है। यहाँ देखाएको छ 30 भनेको यो भित्रदेखि यो सेतोसम्मको 30 भयो। यो 40 भनेको चाहिँ नि यो 40 भनेको यो छेउदेखि यो गारोको यो छेउदेखि चाहिँ बाहिरसम्म जुन पिसिसी निस्केको यो भाग छ, यो टोटल यो भाग चाहिँ कति हो 40 हो। यो छेउदेखि यो भाग चाहिँ कति हो, यतापट्टिको भाग पनि 40 हो। 30 भयो, यो 10 चाहिँ तपछि कति हो 40 हो है। यसरी चाहिँ यो 40 भने यसरी देखाएको हो। यो 40, 30 र 20 को दरले चाहिँ यसरी बसेको छ। यो चारैतिर के छ त भन्दाखेरि यो रेक्ट्याङ्गुलर पोर्सनमा यो सेफ्टी छ भने। अब सोक पिट चाहिँ के छ सर्कुलर छ। सर्कुलरमा यो चाहिँ वाल लगाएको छ नि, यो ह्याच गरेको, यो ह्याच गरेको मोटर वाल हो। यो सेतो चाहिँ जुन चाहिँ ह्याच नगरेको रेक्ट्याङ्गुलर देखाएको छ यो चाहिँ ड्राई ब्रिक वर्कको। तलपट्टि ब्रिक वर्क गरेको छ, मोटर ब्रिक वर्क। माथिपट्टि पनि के छ मोटर ब्रिक वर्क छ र बिचमा चाहिँ के छ ड्राई ब्रिक वर्क छ जसमा मसला लगाएको छैन। यो ड्राई ब्रिक वर्कले के गर्छ त भन्दाखेरि यहाँ भएको चाहिँ लिक्विड चाहिँ मेटेरियललाई के गर्छ सोच्ने काम गर्छ। सोचेर एडजोइनिङ सोइलमा त्यसले के गर्छ ट्रान्सफर गर्छ। अनि यो घेराको चाहिँ एउटा घेरो भयो। यो घेरोभन्दा अर्को घेरो चाहिँ नि यो चाहिँ नि ब्रिक यो चाहिँ ब्रिक एग्रिगेट चाहिँ सोलिङ छ। ब्रिक चाहिँ ढुङ्गाहरू फुटाएको चाहिँ ढुङ्गाको एग्रिगेट सोलिङ गरेको छ चारैतिर है। त्यसपछि स्यान्ड फिलिङ छ। त्यसपछि फेरि अर्को घेरोमा के छ कोर्स स्यान्ड फिलिङ छ। त्यसले गर्दाखेरि अब यहाँनिर आएको चाहिँ नि यो भित्र आएको चाहिँ नि लिक्विड मेटेरियललाई ब्रिकले सोच्छ। ड्राई ब्रिक पछि सोच्यो, यसले ट्रान्सफर गर्यो ड्राई ब्रिक एग्रिगेटलाई। ड्राई ब्रिक एग्रिगेटले ट्रान्सफर गर्यो कोर्स स्यान्डलाई। कोर्स स्यान्डले फेरि यतापट्टि एडजोइनिङ सोइललाई के गर्छ ट्रान्सफर गर्छ र यो सोक पिटमा भएको चाहिँ लिक्विडलाई चाहिँ सोचेर चाहिँ फाल्छ। र सोक पिटमा अब के हुन्छ त भन्दाखेरि सोलिड मेटेरियल मात्रै बाँकी हुन आइपुग्छ। त्यो सोलिड मेटेरियललाई चाहिँ नि केही समयपछि हामी मलको रूपमा युटिलाइज गर्न सक्छौँ। यहाँ हेऱ्यौ भने यो इनलेट पाइप हो, टोयलेटबाट आएको इनलेट पाइप कहाँ झऱ्यो यो च्याम्बरमा झऱ्यो। यो च्याम्बरलाई कसले छेकेको छ त? ब्याफल वालले छेकेको छ। दुईटा च्याम्बर छ यहाँ। यो ब्याफल वालको तलपट्टिबाट कहाँ जान्छ त? डिकम्पोज भइसकेपछि यो अर्को च्याम्बरमा जान्छ र यो अर्को च्याम्बरबाट यो चाहिँ आउटलेट हुँदै यो वेस्ट मेटेरियल चाहिँ डिकम्पोज भएको वेस्ट मेटेरियल कहाँ खस्छ त भन्दाखेरि हाम्रो यो सोकपिटमा गएर खस्छ है। सोकपिटमा झरिसकेपछि सोकपिटले सोच्छ, लिक्विडलाई सोच्छ, अनि सोलिड मेटेरियल जुन बाँकी हुन्छ त्यसलाई हामी म्यान्युअरको रूपमा चाहिँ प्रयोग गर्न सक्छौँ। यो चाहिँ यसको के हो? बेसिक कन्सेप्ट हो है। सोकपिट र सेफ्टी ट्याङ्कको चाहिँ बेसिक कन्सेप्ट के त भन्दाखेरि सोकपिटमा सेफ्टी ट्याङ्कमा आएको चाहिँ नि ह्युमन वेस्टलाई चाहिँ नि फर्टिलाइजरमा परिणत गर्ने। घरमै के गरिन्छ? हाम्रो सेप्टिक ट्याङ्कको मेटेरियललाई घरमै व्यवस्थापन गर्नको लागि हामी सोकपिट युज गर्छौँ। होइन भने सेप्टिक ट्याङ्क भरिन्छ, त्यसलाई पास नगऱ्यो भने सेप्टिक ट्याङ्क भरिन्छ, अनि चाहिँ नि हाम्रो चाहिँ नि गाडी बोलाउनु पर्यो, सेप्टिक ट्याङ्कको वेस्ट बोकेर लाने चाहिँ नि सिवेज वेस्ट बोकेर लाने गाडीलाई बोलाउनु पर्यो, त्यसले पम्प गरिदिन्छ र लिएर जान्छ, सेप्टिक ट्याङ्क खाली गरिदिन्छ, अनि फेरि युज गर्न पाइयो कि होइन? त्यस्तो सुविधा छैन भने के गर्नु पर्यो त भन्दाखेरि यसलाई किन फाल्ने? त्यसै यसलाई युटिलाइज गर्न सकिन्छ, मलको रूपमा युटिलाइज गर्न सकिन्छ भन्ने हिसाब किताबमा चाहिँ नि यहाँ सेफ्टी ट्याङ्क र सोकपिटको दिएको छ। जाँचमा तिमीहरूलाई कहिलेकाहीँ सेफ्टी ट्याङ्कको मात्र सोध्न नि सक्छ, जाँचमा सोकपिटको मात्र सोध्न नि सक्छ, कहिलेकाहीँ दुईटैको कम्बिनेसन गरेर सोध्न पनि सक्छ। जे सोध्छ त्यही उत्तर गर्ने हो। यसमा धेरै आइटमहरू छन्, प्रत्येक आइटम निकाल्न जान्नु पर्यो। जाँचमा जुन आइटम सोध्छ त्यही आइटम मात्र गर्ने, अरू गर्नु पर्दैन है। यो चाहिँ के त? बेसिक कन्सेप्ट अफ द सेप्टिक ट्याङ्क एन्ड द सोकपिट। अब हाम्रो 7:35 क्लास हो। लेट अस स्टार्ट। उसिन त मलाई खान्न भने टाइम खान्न बिहान खान्न। Now this is the quantity calculation for the different items of the safety tank and the soakpit. So I have done this in the tabular format. Okay, calculation of this is the quantity measurement form is prepared here. In the quantity measurement form, there is the table for the serial number, particulars or the items of the work, number, length, breadth, height, quantity, and the remark, and the dimension that is taken from the drawing is another dimension that is not mentioned in the drawing. Then that dimension has to be clarified in the remark table. Okay, so that one person can make the estimate and the second person has to be check the estimate. So how the estimator is taking the dimension from the drawing, that must be that must be stated to the checker. Okay, by using the remark column, so that in the drawing you can look at the figure here. Orthogonal excavation. For the excavation purpose, don't look at the section. Okay, for find the area of the respected item, you have to find the for the excavation. You have to find the area of the excavated portion first, and that is multiplied by the height of the excavation that is seen from the section of the item. Okay, for the excavation purpose, the height is below this is the ground level here. Look at the section here. This is the ground level here. Up below the ground level, we have to excavate the trench. Okay, we have to excavate the trench for the septic tank. That is excavation height is below up to this PCC. Bottom of the PCC, we have to dig the trench, and the soil have to be excavated out. Okay, this is the item for the excavation of the septic tank. Similarly, the ground level is here. For the soak pit, you have to excavate up to this level. Up to this level, the shape is of the circular shape. The shape is not rectangular for the soak pit. The shape is for the septic tank is rectangular shape. So, to excavate all the soil from the below the ground level up to the bottom of the cement concrete or PCC, we have to excavate all the soil, and that soil is excavated and dug out from the ground, and the trench is prepared, and that is filled up by the plain cement concrete over it, and the wall is wall of respected with is constructed to make the box shape for the soak pit chamber. Okay, to make the box shape for the soak pit chamber as shown in the plan. You can see here the for the excavation we have to calculate the length of the trench and the width of the trench. Okay, for the length and width of the trench, consider the plan. The total length of the trench is 200 here, and the 40 here and 40 here. Because total from this inner face of the wall to the end of the PCC, the total width is 40. So it is also 40 here. It is shown in the widthwise direction. That value will be same for this the lengthwise direction also. So this 200, this is given in centimeter. All dimensions are given in centimeter, unless specified here. All dimensions in centimeters, unless otherwise specified. This is in this question. If it is not mentioned with the unit, then that unit is centimeter, is in centimeter. Other unit is given as mentioned here. Okay. Now the total length of the excavation will be 200 plus up to here and up to the PCC. This total length is 20. Up to here is also total length is 20, and 40 and 40 right and 40 left. You will get the 280. Okay. Total length of the trench is 280, and the total width of the trench will be, this is inner part is 90, and the outer part is, this is 40 and this is 40. Total width will be 170 centimeter. That will be 1.7 centimeter. Okay. So you have to calculate the you have to dig the trench of the length of 2.8 meter and the width of 1.7 meter. Okay. You can see from here, and for the calculation of the earth work in excavation, for the septic tank. Okay. Now earth work in excavation. A, for septic tank, there is one number of septic tank. The length of the trench is 2.8 centimeter, and the breadth of the trench is 1.7 centimeter. Okay. That is explained here. How 2.8 is calculated? 2 in internal dimension plus 2 into 0.40 is the total width from the internal dimension to the external part of the PCC, right and the left side of the wall. Okay, which gives that 2 into 0.40. Total will be 2 plus 0.8, which gives the value of 2.8. This is the 2.8, and 1.7 is also similar to the 90 centimeter is 0.90 plus 2 times 40 centimeter 0.40. You will get the value of 1.7. That is 1.7. Now the height is 1.95. How this height is calculated? Look at this figure. Now depth of excavation is generally from this. This is the ground level. From the ground level to the base of the PCC. After this depth, you have to calculate the height. Okay, from ground level to this depth is total depth of excavation. Now you can see here the dimension is not given along this side. The dimension is given from the center of this line. Okay, center of the septic tank, the dimension is given here. This is 30. Below this is the ground line here. Below the ground, this is 30. Okay, and from this water level to the this slope portion, this is 140. Okay, 140 and 30, 170. This is 170. Okay. Now make the horizontal line here. Make the horizontal line here. If you make the horizontal line here, then okay, if you make the horizontal line here, the lower part depth is 20 centimeter is given here. The lower part depth is given as 20 centimeter given here. This is the lower part 20 centimeter. And the slope is this upper part of the slope. This height of the slope is 10 here, given here. This height is given as 10. But there is no slope where there is 0. For the center portion, there is 0 and there is 10. The average height of this, the inclined portion above the rectangular part, this must be 5 centimeter. Okay, this is 10 here, this is 0 here. For the scene, for the center portion, this will be 5. Okay, this will be 5 and 30, 140 plus 5, 175 plus 20, 195. Okay, total height will be from ground level to the bottom of this PCC. Total height will be 30 plus 140 plus this 5 plus this is 20. You will get this value as if you add 195. If you add all this value, you can find the total centimeter as 195, and that is converted into meter as 1.95. Okay, so that I have calculated the height as 1.95 meter here. 1.95 meter here. Okay, 1.95 is 0.3030, 1.40, 0 plus 0.10 divided by 2 average height for the triangular portion. The height is 10 centimeter at the height, and at the another side there is 0 height, so the average height is 5 centimeter. Okay, plus the depth of the rectangular portion of the PCC below the 0.50 0.05 centimeter. That height is 20 centimeter given in the figure. So total height will be 1.95. This value is put here: length, breadth, and height. You have to mention how these dimensions you take while measuring the quantity. You have to mention in the remark column. Okay, so that one can easily understand how you take the value of 2.8, 1.7, and 1.95. Okay, and he can check your estimate whether you did the estimate correctly or not. Okay, so for checking purpose, you have to mention the dimension that is not mentioned directly in the drawing. That has to be provided in the remark column. Okay, this is the way of calculating the quantity. Now length, breadth, and height, and the number is multiplied, you will get the value of 9.282 cubic meter. Now let us move to the excavation for the septic tank is over. Now look at the excavation for the soak pit. For the soak pit, the excavation should be done for the up to the bottom portion. Up to this bottom portion. This width is diameter of this is the rectangular shape. You can say in the section the rectangular shape is shown here, but this is not the rectangular section. So that inside portion, this inside diameter is 100 centimeter. Okay, this white portion is this inside diameter, and this part is 20 centimeter. This part is 20 centimeter because the brick work is of 20 centimeter width. This is 20 centimeter. Okay, and the diameter of this lower portion, this lower portion diameter is 100 plus 20 plus 20, 140 centimeter. That is 1.40 meter. Then you have to excavate the trench of the larger trench from this to this up to this height. Up to this height from ground level to this point, up to this point, you have to excavate the trench of this diameter. of this diameter. Okay, the whole diameter of this circle, outer diameter of the circle, up to this height, you have to dig the circular trench. Okay, circular trench. The diameter of the circular trench is 100, 140, 170, and 200. Total diameter of the circular trench is 200 centimeter, that is 2 meter. Now the volume of the trench will be the area of the circle into depth of the trench. Okay, the area of the circle into depth of the trench. The area of the circle will be pi d square divided by 4. The pi into diameter of the circle is 2 meter. Total diameter of the circle is 2 meter. Okay? Pi 2 square divided by 4 into the height of the circle. Look at the height of the circle. And this is 50 here, 50 centimeter here. Up to here to here, this is 250. 250 and this 50, which gives the value of 3 meter. Okay, which gives the value of 300 centimeter, that is 3 meter. Up to this height, up to this 3 meter height, the width, the diameter of the circle is 2. So you have to excavate the trench of 2 meter diameter circle up to the height 3 meter. So for the upper portion, so I have calculated here for the top portion of the soak pit, one, the pi into diameter is pi d square divided by 4. This is the top portion. This is diameter. 2 meter is 2 meter. So the pi d square by 4 is the area of the top portion. Okay, circle. And the height of the excavation is 3 meter. Okay, 250 plus 50, 300 centimeter, which is 3 meter, which gives the area into depth, which gives the volume as 9.425 cubic meter. And for the bottom portion, look at this. For the bottom portion, the diameter of this bottom portion, you look at the diameter of this bottom portion. This is 100 plus 20 into 20 and 20, 140. You can dig the small trench below the bigger circular trench. Okay, this diameter is required here for the 20 centimeter height. Okay, the total diameter is 1.40 meter. 100 plus 20 plus 20, 140 centimeter, that is 1.40 meter. The diameter is of this circular shape. Again, this is circular shape. This is 20 here. This is circular shape. So the pi into 1.4 square divided by 4 into height is 0.20, 20 centimeter is here. So this is for the bottom portion. Okay, this bottom portion is calculated like this. Now, soak pit bottom portion, one number, pi into 1.4 square divided by 4 area into height of the bottom portion is 0.20. You will get the volume as the area into height. You will get the 0.308 cubic meter. Now total excavation, earthwork excavation will be excavation for the septic tank and excavation for the soak pit. You will get the value of 12.185 cubic meter. Okay. Hello. Hello. यो गरेको बुझ्यौ?
बुझे सर, बुझे।
ल अब आजलाई यति नै भयो। टाइम पनि सक्यो। अब 7:30 सम्म हो, 7:39 भइसक्यो है। अर्को दिन म पीसीसी, फर्स्ट अग्रीको रेजिमेन्ट प्लाटर के छन् बाँकी भएको जम्मा लटाइटुटुङ अर्को दिन क्लासमा गरौँला। आजलाई यति नै भयो है त। सेप्टिक ट्याङ्कको अर्थवर्क एक्सट्राक्सनसँग गरेर छ, नभए अर्को दिन सेप्टिक ट्याङ्क फेरि म रिभाइज गरौँला। जसले आज यो बुझेको छैन भोलि अर्को दिन पनि फेरि म यसलाई रिभाइज गरेर बुझाउने कोसिस गर्छु। अब हामीले के हेर्नुपर्छ त घरि यो चित्र र यो सँगसँगै राखेर हेर्नुपर्छ है। त्यो घरि चित्रमा जानु पर्यो, घरि यता आउनु पर्यो, घरि चित्रमा जानु पर्यो, घरि यता आउनु पर्यो। त्यसले गर्दाखेरि अलिकति कन्फ्युजन चाहिँ हुने जस्तो देखिन्छ है। त्यहाँ चित्र बुझ्नुभयो, जसले चित्र बुझ्दैन त्यसले क्वान्टिटी निकाल्नै सक्दैन। डाइमेन्सन र चाहिँ नि ड्रइङ र डाइमेन्सन जसले बुझ्दैन त्यसले क्वान्टिटी निकाल्न सक्दैन है। अनि कन्सेप्ट बुझ्नु पर्यो। फेरि ड्रइङ बुझेर मात्रै भएन, अनि फिल्डमा यो यस्तो हुन्छ है भन्ने कुरा कन्सेप्ट बुझ्नुपर्छ। चारैतिर वाल लगाएको हुन्छ, भित्रपट्टि चाहिँ के हुन्छ खोक्रो हुन्छ एउटा चाहिँ बक्सा जस्तो त्यो बक्सामा चाहिँ के आउँछ त भन्दाखेरि पाइपले फोहोरलाई लगेर त्यहाँ विसर्जन गर्ने हो त्यसलाई हामी सेप्टिक ट्याङ्क भन्छ होइन त ल अब यहाँ दिएको छ त्यही अनुसार गर्ने अब अर्को दिन गरौँला लेट मी